Hi, this is Mrs. Ward, and these are the notes for the second half of the section 2.1, the derivative in the tangent line. So we talked last time about how to find the derivative of a function by using the limit definition of a derivative, and we're still going to use that limit definition of a derivative, and we're still going to find the tangent of a function at a certain point and find the equation of the tangent line. And I just wanted to do a couple problems since we're not there face to face to go over them in class. So here we go. So number 23 is from the set that you had from homework last night. Just wanted to do a real quick recap of what that was. You're taking the limit as delta x approaches 0, and you're doing the f of x plus delta x minus f of x over delta x. And that's a formula you're expected to know. If I ask you to find the derivative using the limit definition, this is what it's asking for you to substitute into this formula. So I am going to go ahead and substitute in. So I'm going to have the square root of x plus delta x plus 1, that's all underneath the square root sign, minus the square root of x plus 1. And this is all going to be over delta x. And the limit definition means that I'm taking the limit as that delta x approaches 0. Remember, it's taking the secant line, making those points closer and closer together to actually make it a tangent line. So in order to do this, if I substitute in 0, I would get 0 out of 0, which tells me that I can do something to simplify it. So what I'm going to do, if I have radicals, I'm going to multiply by the conjugate, and it looks a lot nastier than it is. So I'm going to multiply by the square root of x plus delta x plus 1 plus the square root of x plus 1. If I multiply the numerator by that, I have to multiply the denominator by the exact same thing to keep my fractions equal. So when I do that, I am going to have, this will still be the limit, as delta x approaches 0. When I take the square root of x plus delta x plus 1 times the square root of x plus delta x plus 1, that's just simply going to be x plus delta x plus 1. There will be no middle term because I multiplied by the conjugate, which means that the middle term is 0. So this will be minus, and then x plus 1. I'm going to put that in parentheses, so remember to distribute that negative sign times that entire second half. And this is all over delta x times all of that. And I'm not going to try and simplify that. I'm just going to leave it like that for right now. Now I am going to switch colors. I'm still taking the limit as delta x approaches 0. Now when I distribute this negative sign, this will be negative x minus 1, which means the x's will simplify and the 1's will simplify. So I'm left with delta x over delta x times x plus delta x plus 1 plus x plus 1. Here the delta x's will simplify. And then since delta x is approaching 0, so there will be a 1 up here. This delta x is approaching 0, which means in this delta x here, I'm going to write 0. So I'm going to have the square root of x plus 0 plus 1. Whoops, forgot my 1 there. Plus the square root of x plus 1. And this is all over 1. I don't have to write the limit anymore because I used that limit. So I have 1 over, and I have 2 of these. So 2 times the square root of x plus 1. And that would be my derivative equation. And that's all you had to do for the first ones. I just wanted to go through one that might look a little bit more complicated, just to refresh your skills. Okay, next one, number 25 through 32, is saying find the equation of a tangent line to the graph at the given point. Then use your graphing utility to graph the function in its tangent line at the point, and then use the derivative feature. Oh, we're not going to do that yet because I'm not going to tell you how to do that yet. I'm sure someone will figure it out, but we're not going to do that right now. All right, so this one, I have this function. I want to find the equation of the tangent line, so I'm going to find the slope of the tangent line at this point. So first thing I'm going to have to do is find the slope of the tangent line. To find the slope of the tangent line, that means I have to find the derivative, which means I'm going to do that x plus delta x squared plus 2 times x plus delta x plus 1 minus f of x, which is x squared plus 2x plus 1. And this is all over delta x. And to find the derivative, I'm going to erase this because I'm finding the derivative. I am going to set that equal, I'm going to take the limit of this whole thing, so there's no equal sign, as delta x approaches 0. So when I square this, I'm going to have x squared plus 2x delta x plus delta x squared, distributing the 2 plus 2x plus 2 delta x, and there's that plus 1, distributing the negative sign, minus x squared minus 2x minus 1. This is all over delta x, and I'm taking the limit as delta x approaches 0. I don't want to forget what I'm doing, so I like writing it every single time. Who am I kidding? I'm going to take off if you don't write it, so write it. Here we go. The x squareds will simplify. The 2x's will simplify. The 1's will simplify, and they'll all equal 0. Everything that I have left, every single term has a delta x that I can factor out, so I'm going to do that. Next step. So I am going to factor out delta x, and I will be left with 2x plus delta x plus 2. And this is all over delta x. Very conveniently, the delta x's simplify. If they don't simplify, you did something wrong. So then I have the limits as delta x approaches 0, and I'm left with 2x plus, in place of that delta x, I'm going to write 0 plus 2. So my derivative, the equation of my derivative is going to be 2x plus 2. So that's the first part, finding the equation of the derivative, or the equation of the tangent line, the slope of the tangent line. They want it at the point negative 3, 4. So now I want to find the derivative at negative 3. So this will be 2 times negative 3 plus 2. So that's negative 6 plus 2. Ooh, the parentheses there, plus 2 is there. So negative 6 plus 2, and I get negative 4. That's my slope of my tangent line at that point. So now I have a slope at that point. So my slope at that point is negative 4, and I have that point, which was negative 3 and I think 5. Going up to check. Oh, nope. Negative 3, 4. So if I have a slope and I have a point, I should be able to write the equation of the line. So the equation of the tangent line, I'm going to take y minus the y coordinate, because you know I'm a point slope person, times my slope times x minus negative 3. So x minus negative 3. So this will be y minus 4 is equal to negative 4x minus 12. So y is equal to negative 4x minus 8. And that is the equation of my tangent line. And I'm going to graph that. So hold on. So I went to my calculator and I graphed the original function, which was x squared plus 2x plus 1, which is the blue. Graphed my tangent line, which was negative 4x minus 8. And I'm checking for the tangent line at the point negative 3, positive 4. So it looks at negative 3, positive 4 is pretty much where that tangent line is. So that's, and you'll notice that the tangent line looks like it hovers over the line, but if you were to zoom in really tight, you would see that technically it only like touches at that one exact point. So that's just on the graph, and that's what it looks like. The next one, in exercises 33 through 36, find an equation of a line that is tangent to the graph of f and parallel to the given line. So the first thing I'm going to have to do is find the equation line that I'm going to have to find the equation of the tangent line for this, and then work on it being parallel to that. So here we go. So I'm going to find the derivative of this by using the limit formula. So I'm going to say the limit as delta x approaches 0 of x plus delta x raised to the third minus x to the third, and this is all over delta x. Now, technically, I'm taking this x plus delta x times itself 3 times, but if I remember Pascal's triangle, which is why one of the reasons why we learned Pascal's triangle, I'm just going to go over here, 1, 1, 1, 1, 2, 1, 1, 3, 3, 1. I'm using this row here. This looks familiar to everyone. And I'm going to make that table, and I'll do that over here while I'm here. And then this will be my x, this will be my delta x, and we start off with delta x to the third. This should look familiar to you, yes? I hope so. That's the third. So when I do this, that'll be the limit. As delta x approaches 0 of x to the third plus 3x squared delta x plus 3x delta x squared plus 1 delta x to the third, and this is minus x to the third, and this is all over delta x. So remembering Pascal's triangle makes expanding this a whole heck of a lot easier. So now I'm going to simplify what I can simplify. So the x to the third should equal 0. I'm still taking the limit as delta x approaches 0, and I end up with, I'm factoring out the delta x when I'm at it, 3x squared plus 3x delta x plus delta x squared, and this is all over delta x. The delta x's will simplify. I'm still taking the limit as delta x approaches 0. And when I do that, I'll have 3x squared plus 3x times 0 plus 0 squared. So this all will boil down to, the derivative will all boil down to 3x squared. So that tells me the equation of the tangent line of the function. So I know the equation of my slope of my tangent line is going to be this 3x squared. And I want to be parallel to this line up here. So I have to find the slope of this line up here. So going down here to find this slope, I'm just going to take the y over to the other side and have 3x plus 1 is equal to y, which means the slope of this line is going to be 3. So if these two things are going to be parallel, that means I need to find the x value. When I substitute it in, this x value will give me a slope of 3. So I'm solving for x. So x squared is equal to 1, divide both sides by 3. So x is equal to plus or minus 1. So those are my x coordinates, plus 1, negative 1. And I'm putting them both back into this original equation. So the points that I have for the places where the tangent line will be parallel to that other line are going to be 1, 1, and negative 1, negative 1, because that's x, and this y would be x to the third. And then to find, and it says, find the equation of the line that is tangent. So now I have to come up with an equation of that line. So now this is the point that I have, and this is the slope is 3. So I'm going to say y minus 1 is equal to my slope times x minus 1. So that'll be y minus 1 is equal to 3x minus 3. So one equation is y is equal to 3x minus 2. And then doing negative 1, this will be y plus 1 is equal to 3 times x plus 1. So y plus 1 is equal to 3x plus 3. Y is equal to 3x plus 2. And those are the two equations of the tangent line to this graph here that are parallel to that graph there. So what this line did is it told me what to set my derivative equal to. It told me to set my derivative equal to 3. Okay, moving on to the next one. In exercises 43 to 46, sketch the graph of the derivative, explain how you got it. So when I look at this, remember the derivative is the slope of the tangent line, which the slope of the tangent line is the rise over the run at a given point. So when I'm looking at 44, if I asked you what is the slope of this line every single time, you're going to tell me the slope of this line is 0. It's a horizontal line, which means that the tangent, the derivative of this graph is just going to be 0 because the slope is always 0. So the derivative is going to be a horizontal line at 0. When I look at 46, 46 is slightly different. When I look at this, my derivative from here to here, my slope is a -1. But when I look from this point here to this point here, my slope is a +1. Remember, this is a sharp turn. At the sharp turn, the derivative is undefined. Undefined derivative. So when I go to graph the derivative, and I'm graphing the derivative in red, and I'm probably going to erase all this other stuff. Well, I probably shouldn't have done that, but I did too late now. So we said for up to 4, my derivative is going to be 0, is going to be -1. So it's going to be -1, like from here to here, and then we put an open circle to highlight that there is no derivative at 4. And then from here on, my slope is a +1. So it goes something like that. So that would be the graph of the derivative of the function. Moving on to the next one. It says sketch the graph of the function of a derivative. I'm going to do 48 and 49 of these two. I forgot to tell you that, but that's what I'm doing. 48, sketch the graph of a function whose derivative is always positive. So in order to do that, I have to graph a function that's always increasing. So it could be something like this. That would work for 48, because let's say the slope of this line was, let's say the slope of the line was like 5. Then my derivative, sketching my derivative in blue, would be 5, which is always positive, because 5 is positive. If I did something like this, if I want to get more creative, I can think of another function that's always increasing, and the one that I'm thinking of right now is something like x to the third, something that goes like that. That's always increasing. So that would be another example where the derivative is always positive. So remember, there's more than one right answer. So 49 says the limit of f of c for a function f and a number c, find f and c. So they want me to find the function, and they want me to find the value of the function, or what x value. So when I'm looking at this one, I have 5 minus, and then remember, to do this, I'm going to take, this was going backwards, this was the limit, and then you had delta x approaches 0, and this was f of x plus c. No, that was not. Oh, I messed it up. Let's try that again. I would love to edit, but I don't know how. Maybe someone can tell me how to edit. So here I'm going to have f of, and then this will be c plus delta x minus f of c all over delta x. So if I look from here to here, this is my c plus delta x. So now I can plainly see that c is going to be 1, I hope. We'll find out in a second. And my function is going to be 5 minus 3x. So my function is 5 minus 3x. And then if I'm having a good day, and I certainly hope that I'm having a good day, if I put this 1 in here, if I find f of 1 and put that in there, 5 minus 3 times 1, I get 2, which is what they have here for f of 1. So that would be my function, and c would be my 1. So that's what they're asking you to do. They're asking you to work backwards. They already substituted in this formula, and they want you to figure out what you substituted in. I personally think it's easier to write this and then try and match it up to that. Okay, looking at the next one. It wants an exercise, identify the function f that has the following characteristics, then sketch the function. I find it easier to sketch the function first and then try and figure it out later. So they tell me that f of 0 is equal to 4. So at 0, I'm going to plot the point 4. They tell me the derivative at 0 is 0, which means either I'm a horizontal line or it's like a vertex of some sort. They tell me that the derivative is less than 0 for values when x is less than 0, which means my function is going down. My slope is going down. My slope is negative, which means my function is going down, or I like to say decreasing. And then when f is greater than 0, my function is increasing. So my slope is positive. So what I'm thinking of, and yes, there are multiple ways you can do this, but let's just do a simple one. I'm decreasing. I hit this point, and then it's like I don't really increase or decrease, and then I start to increase up. So the easiest thing for me to do is draw a parabola. So that's what I drew. So remember, there's more than one shape that will match this, but that's probably the most efficient way for me to draw that. When I look at the next one, it says describe the x values for which f is differentiable. In other words, when can I find the derivative? So one of the things that we talked about last class is your function has to be continuous in order to find the derivative. So here, my function is discontinuous at x is equal to -1, which means I cannot find the derivative at -1. Everywhere else looks like it's fine. So I'm going to say I can find the derivative, so it's differentiable. Everywhere except when x is equal to -1. So looking at 82, I put 82 on here on purpose because this is one of the hardest ones that you guys have a problem with. Is 82 is continuous. The whole thing's continuous. It doesn't have a gap. I can find the limit every time. I'm good. It's a continuous function that always has a limit. But when I look at this and I'm graphing this, I go from here my slope would be negative. And then I don't even have the time to take a breath, and then all of a sudden it starts shooting up. So at these sharp points here and here, those are called sharp turns, the derivative cannot be found because when I'm to the left of -3, it's a negative derivative. When I'm to the right of -3, it's a positive derivative. So at -3 and +3, it's not going to be differentiable because of those sharp curves. So that happens with some absolute values are a good one when that usually happens, when you have that really super sharp curve. So you cannot find the derivative at those sharp points. And the other time is when you have a graph that does something like this. I'm going to try and draw it something like, I don't know that I did a very good job of that. Something where, like, if I tried to do the tangent line, it would be a vertical line. You have to watch out for those ones too. So I tried to do one of each type. I hope I did. If you have any questions, email me. Remember, the collaborative room is open, so you can come in there between 11 and 1 on weekdays. And if you have any questions, email me. Best of luck.